For aircraft safety, why optics is important is because, okay, because everything, okay, everything. See, aircraft industry is a very, it should be a soundproof industry, right? No mistakes can be pardoned, right? Because if there is, even if there is a small mistake, there can be a catastrophe, and so many lives can be lost, right? So it has to be a no mistake industry, right? The quality standards should be very high in aircraft industry. Okay. Now, with respect to optics, now how we determine optics, the primary sense that we use to determine quality, to make judgment, right, to see each and everything, is our eyes, isn't it? Even if the pilot is flying the aircraft, he assumes takes all the decision based on his vision, right? You cannot rely on a blind person to fly the aircraft. Similarly, right, all the ground staff, everybody who is working with making the aircraft serviceable and fly, everybody should have good vision, and they should be able to recognize different things, right? So you see, this is the basic crux what I am saying. To make the aerospace industry safe, to make the aerospace industry safe, the primary sense that you are going to use is not your touch, not your hearing ability, not your feeling, not your taste, but your vision, right? So if you're using your vision to determine the safety of the aircraft, right, so there are many different things that you must be able to visualize, right? So from here originates the aircraft safety. For example, okay, very simple question, okay, very simple question I like to ask you, okay, very simple question I like to ask you, right? So do you know what kind of mirror is being used in a rear view mirror of a vehicle? It might be a bike, it might be a car, right? So we have a rear view mirror, right? So what kind of mirror is being used in that rear view mirror? Convex mirror, right? So you see, Rajaningam, you know what is a convex mirror. You know what is a convex mirror. Then you know the properties of a convex mirror. The first property is that the objects, right? The objects in a convex mirror, they seems to be far away than they actually are. Yes or no? See, you know this because you have studied optics. A person who is from, say, who has not studied optics will not know this. He will not know what is a convex mirror. He will not simply know the thing that in a convex mirror, the image is actually, it looks far away than it is actually is. Right? That is because the size of the image is reduced. In a convex mirror, the size of the image is always reduced. So you see a smaller image, so you feel that the object is far away. So if you don't have this idea, there is a chance of making mistakes. Right? Now, in ground, it is still allowed. Mistakes are still allowed in ground because you might not have a very devastating, catastrophic mistake, right? But mistakes are not allowed in the aircraft industry on air. That is why the importance of optics is paramount in the aircraft industry, and that is why it is also there in your syllabus. That is why it is there also there in your syllabus. So without wasting any time, let us start the chapter optics. Without wasting much time, let us start the chapter optics. Okay. So the first thing, let us talk about light. Let us talk about light. So optics is all about light, right? Optics is all about light. Optics is all about light. Now, light belongs to an electromagnetic spectrum. I'll not go much detail into this. Okay, belongs to, or let me say, visible light. because visible light, that is what our eyes can see. That is what our eyes can see. Visible light is nothing else but what our eyes can see, belongs to, it belongs to electromagnetic spectrum having wavelength from 400 nanometer to 750 nanometer. So this is basically the VIBGYO range. Which range I'm talking about? I'm talking about the VIBGYO range, right? 400 nanometer to 750 nanometer. So light is basically an electromagnetic spectrum. Electromagnetic spectrum have many different wavelengths. Visible light, what our eyes can see. Visible light, if I say what our eyes can see, it is from 400 nanometer to 750 nanometer. So this is the wavelength range. Okay. Now, what is the speed of light in vacuum? Who can tell me? What is the speed of light in vacuum? What is the speed of light in vacuum? Yes, very nice, fantastic, right? The speed of light in vacuum is equal to 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second. So these are the two small things that you should know, right? Okay. Now, we don't have the liberty of time that we keep on discussing each and everything. I'll just go through the main important points, and mostly the questions that will be asked will be numerical from optics. Generally from optics, theoretical questions are not being asked. Mostly it will be from numerical, so we'll focus more on the numerical part. Law of reflection. So I hope that all of you know what is the law of reflection. What is law of reflection? What is law of reflection? So the law of reflection says that if there is an incident ray, then it is reflected, and suppose you have a normal, then in this case, let me say this angle is theta, this angle is also theta. The angle of reflection is equal to angle of incidence is equal to angle of reflection. This is the incident ray. Incident ray, reflected ray. So what does law of reflection says? Law of reflection says that angle of reflection is equal to angle of incidence. Okay, which one is the angle of incidence? This one is the angle of incidence. Which one is the angle of reflection? This one is the angle of reflection. So this angle is equal to this angle, right? This angle is equal to this angle. See, I believe, Tika, I can't see your faces, but I believe that whatever we are teaching, whatever I'm teaching, this is something you already know, right? So I will just try to be a little bit fast. Now give me a reply. Do you know all these things? Are you comfortable if I go a little bit fast? Means I'm not going to ask you each and every time, understood, is it understood, have you understood this, is it clear? I'll just keep on teaching so that we can go on to the problem. I want to do two problems today. Yes. Uttam is saying fast. I just want the answer from everybody. I hope that you are there. Raja Lingam is also saying yes. What about others? Thankar, Rakesh, Pranati. Shall we go fast? Right? Great. Very nice, very nice, very nice. Fantastic. So this is what is known as the law of refraction, right? So quickly let us go through the sign convention. Let us quickly sign convention, right? For reflection in spherical surfaces, right? Let us go through sign. Okay, previous slide. Yes, please. Okay, so sign convention for reflection in spherical surfaces. So directly we'll do spherical surfaces, right? Reflection in spherical surfaces, right? So directly let us do a spherical surface. So let me say this is a mirror. What kind of mirror is this? What kind of mirror is this? This is a concave mirror. Very nice. Okay. So this is x-axis. Okay. So we consider this point as the origin. Okay. This point P, let me say it is known as the pole. The point P is as origin. So from right hand side of the point P it is positive. Towards left of point P it is negative. Okay. Towards up of point P it is again positive, and towards down of point P it is negative. Right? So this is the sign convention. Right? So if you replace the concave mirror by a convex mirror, nothing is going to change. Okay? Everything same. So simply right and towards right, you can just imagine that the point P is nothing else but the origin. Right of origin positive, left of origin negative, top of origin positive, below the origin negative. Okay. So there are three important terms in a spherical mirror, and they are the focus, the pole, and the center of curvature. The focus, pole, and the center of curvature. Let us try to understand what is focus, pole, and center of curvature. Let us try to understand what is focus, pole, and center of curvature. So let me say this is a concave mirror. You can take a concave mirror or you can take a convex mirror as you wish. So not much difference. Let me say this is point P. This point P is known as the pole. Then we have a point F, which is known as the focus. And then we have a point C, which is known as the radius, the center of curvature. E, F, C, curvature, right? The distance CP, the distance CP is nothing else but R, that is equal to radius of the mirror, and the distance FP I'll denote as by small f is nothing else, it is known as focal. Okay. So guys, if you have any doubt, see, it is very important that you clear the exam. Okay. So don't, even if there is a minor doubt, please do ask. I'm going a bit fast. I can't see your faces. I can't see your copies. If you're, is it clear or not? But I'm giving you a clear cut instruction. Whenever you have any doubt, suppose you have not understood what is FP. So, what is FP? Focal length. What do we mean by FP? Right? You can ask. But I'm assuming why I am going fast is because that I'm assuming that you have done this lot many times in your class 12, and I feel that you know a lot of this, but still you have the complete right, to ask. Right? So this is nothing else but the case. Right? So what is the use of focal length? What is the use of focal length? So basically any ray which comes parallel to the principal axis. This axis is known as principal axis. Principal axis. So any ray which comes parallel to the principal axis after reflection is passes through the focus, and vice versa is also possible. Suppose if a ray passes through the focus, after reflection it will become parallel to the principal axis. Right? So if we have an object here, let me say, if there is an object somewhere here, so the image of the object you can see will be formed somewhere here. This is the object, and this will be the image. Right? And any ray which is passing through the center of curvature will be reflected back through center of curvature. Any ray which is passing through the center of curvature, if there is any ray which is passing through the center of curvature, if there is any ray which is passing through the center of curvature, it will also be reflected back through center of curvature. Any ray which is passing through center of curvature will also be reflected back through center of curvature. Okay, so this is how a image is being formed. Right? So now you might remember, okay, we will do some questions and we will try to figure out, okay, few things. We'll do some questions and we'll try to figure out some things. Okay. Now, uh, this is a convex mirror. And in convex mirror, both real and imaginary images can be formed. Okay, now we'll try to do it using a problem. We'll try to see that using a problem. But in convex mirror, all the images are imaginary, right? All the images will always be imaginary, right? There will be no real images in case of any convex mirror. We'll see that through a problem. Now, small angle of incidence, right? There is an assumption. There will be an assumption here. There will be an assumption here shortly. Okay. So let me mark the pole me say this is the pole, this is the focus, this is the center of curvature. Now what I have, let me say this is the incident ray. After it strikes the mirror, it will get reflected through the focal length. Okay. Now suppose you join these 2 points. Which point? Suppose the center of curvature and the point of incidence. So these angles are the angle of incidence and angle of reflection. We say this is angle theta. Angle of incidence and angle of reflection. This is the incident ray. And this is the reflected ray. Now for small angle of incidence, we can prove that for small angle of incidence, we can prove it, but I'm not proving it here, right? The focal length is equal to radius of curvature divided by 2. For small angle of incidence, the focal length is equal to radius of curvature by 2. So which one is the focal length basically? This is the focal length f. This is the focal length f. And which one is the radius of curvature? This is the radius of curvature. So the focal length is basically half the radius of curvature. Okay, so let us go on to the next topic, that is equation of mirror or mirror equation. Okay, you can also tell me if I'm going faster. Okay, if you want me to reduce my speed, okay, if you want me to reduce my speed a little bit, then also you can say me. If you want me to increase my speed, then also you can say me. Okay, so the mirror equation can be written as the mirror equation can be written as 1 divided by v plus 1 divided by u is equal to 1 divided by f. Or this can be simplified. This can be simplified to v is equal to uf divided by u minus f. So both the equations are same. Both the equations are same. You can remember whichever you want. You can remember whichever you want. So what is v here? V is the image distance of the object from mirror. What is u here? Object from mirror. What is f here? Focal length. There is one more formula that is known as lateral magnification. There is one more formula that is known as lateral magnification. Lateral magnification is represented by m. This is equal to lateral magnification is represented by air. It is equal to minus of V divided by U is equal to size of image, or you can simply say height of image divided by height of object. So tell me if it is clear till now. Give me a yes if it is clear till now. If you have any doubt, if you want to see anything, because now this is all about.
सर
Yeah, tell me.
सर यहाँ पे this minus is for direction or this is something else, sir?
Yeah, see, you'll get to know when we solve. It is actually minus sign is basically, see, when we are using a, whenever we एक काम करते हैं, we'll do one thing now. As soon
Okay.
as we start the problem, you'll get to understand,
ठीक है सर. Okay sir.
because now we are quickly dealing with the equations, very simple equations. If you remember these two equations are the most important equation. एक बार question करेंगे, then you will be able to understand each and everything properly. Okay,
ठीक है
Shankar?
सर. Okay sir. ठीक है सर. कोई दिक्कत.
So any other point? Anybody else? Okay, let us try to do a question. Okay, let us try to do a question. An object is placed at 10 centimeter, and second time it is placed at a distance of 5 centimeter in front of a concave mirror. Of radius of curvature 15 centimeter. Find the position, nature, and magnification of the image. You see, very simple question है, ठीक है ना? और question, there has been only one question, ठीक है ना, in the previous papers, and by looking at that question, this kind of question might be asked. ठीक है? This is the simplest question possible. An object is placed at 10 centimeter, so this is part one, right? In front of a concave mirror of radius of curvature 15 centimeter. Find the position, nature, and magnification of the image. जल्दी करो. Try to do it fast. Let me see. Part 1. Tell me the position, nature, and magnification of the image. Very nice, fantastic. So position, nature, and magnification. So you have given me the position, right? It is minus 30. Can you write it? What is the position, nature, and magnification of the image? Very good. Okay. So एक बार देखते हैं. This is the mirror, right? So what is the distance CP? CP is 15. The distance CP is 15. Magnification is 3. So if I am saying 3, let us see what exactly does it mean. ठीक है ना? So CP is 15. तो पहली बार में the first time the object is placed at 10 centimeter. If it is placed at 10 centimeter means this is the object. This is the object, right? It is placed at 10 centimeter. So U is equal to 10. Okay. So where is the image form? You can see the image is formed somewhere here. The image is formed somewhere here. So इसी से idea लगा. You can take out the idea from here itself, right? So CP is 15. CP is 15 given in the question. What is the magnitude of CP? CP is equal to 15. So if CP is 15, what is the focal length? Focal length is nothing else but FP. That is equal to 15 by 2. That is 7.5. Basically, I should say minus 7.5. Okay, I should say minus 7.5. Okay. Okay. So what is the value of U here? I'll say minus 10. Minus 10. Why minus 10? Because it is left of the point P. So what is the value of F? Focal length. That is equal to minus 7.5. So can you find out what is V? V is equal to UF divided by U minus F. That is equal to 15 into, sorry, minus 10 into minus 7.5 divided by, what is U? U is minus 10 minus 7.5. So if you calculate, this is going to come out to be minus 30. It is coming out to be minus 30. Means this distance is nothing else but 30 centimeter. This distance is U, that is 10 centimeter. So the image is formed at a distance of 30 centimeter from the image is formed at a distance of 30 centimeter from the mirror. Right? Now let us try to calculate what is the magnification. Magnification is given by minus V divided by U. Minus V divided by U means minus of, what is V? V is minus 30 divided by U. U is minus 10. You substitute everything with the form, with the sign convention. So what will M equal to? M is equal to minus 3. So M is equal to minus 3 is representing that the image is 3 times, and the minus sign is representing that it is pointing toward downwards, means it is inverted. Getting my point? If I say minus, What is the meaning of minus? Minus means it is going below the principal axis. Everything is validated from the image, isn't it? Tankar, is it clear? So the minus sign helps us to give us, if you, the minus sign does not mean that the image is real. Image is real or imaginary, it will be given by this minus sign. If it is minus 30, if it is coming out to be minus 30 centimeter, definitely image has to be formed towards left of the focal point. Right, Uttam? This minus is saying that the image is imaginary. Sorry. Image is real. This minus sign is saying that the image is real. What is this minus sign saying? That the image is inverted. That the image is inverted. Right? So what kind of image you have? You have the image at minus 30 centimeter, right? Image is real, inverted, and a magnification of 3, matlab 3 times size. Any doubt? Try to solve it keeping 5 centimeter. Try to solve it using the second part. Okay? The object is placed 5 centimeter above the in front of the concave mirror. Let us see what kind of result it will give us. Let us see what kind of result it will give us. Okay. Pranati, give me the full answer. Good. You've come up with 15, give me the full answer. Right? Try to express it in your word. When you try to express it in your word, right? What kind of image? What is the nature of image? Right? Is it real, inverted, imagery, erect, and magnification? Everything. So here, okay, if you place here the second case, the object is placed between the focal length and the focus and the pole, right? Because this distance is 7.5. This distance is 7.5. The focal length FP is 7.5. So it is placed. The object is placed between the focal length and the pole. So we'll consider two types of rays here. We're going to consider two types of rays. The first ray is going parallel to is moving parallel to the principal axis, and after reflection it is passing through the focus. The second ray, it is passing through the center of curvature. Now we know if a ray passes through the center of curvature, the incident ray and the reflected ray will be the same. Now you can see these two rays are diverging in nature, so definitely it is never going to meet this side towards left. What we have to do, we'll have to extend them backwards, and when you extend them backwards, you will get to see that these two lines intersect somewhere behind the mirror. So wherever these two lines intersect, right, the extension, the image will be formed there. The image will be formed there. So you can see what kind of image. The image is imaginary. The image is erect. The image is magnified. Right? From this diagram itself, I can say the image will be imaginary. Right? It is erect. Right? It is not upside down, not inverted. Erect. E-R-E-C-T. E-R-E-C-T. Erect. And it is magnified. And it is magnified. Now let us try to find out the same using calculations. So what is the formula for V? V is equal to, we know that it is UF divided by U minus F. So what is U here? Here U is minus 5. What is F here? F is minus 7.5. What is U here? Minus 5 minus 7.5. So minus 5 minus 7.5, so it is coming out to be plus 15. So you see, plus 15 means the image is towards right of point P, right? What is the magnification? Magnification is equal to minus V by U. So this is equal to minus 15 divided by minus 3. Sorry, not minus 3, minus 5. So this is also is equal to 3. So you see the magnification is again 3 times, but this time magnification is coming out to be positive. What does positive sign means? The positive sign means that it is erect. It is erect. The image is erect. Is it clear? Please give me a yes if it is clear to all of you. Tirthankar, Rajalingam,
सर
Rakesh.
सर
Yeah,
ये
tell me.
साइन वाला नहीं समझ आ रहा है सर, ये यू का प्लस हो रहा है, वी का प्लस माइनस हो रहा है, ये नहीं समझ आ रहा है सर, बाकी तो अंडरस्टूड.
ठीक है, ठीक है.
प्लीज सर
इसको
इफ यू
जल्दी
कुड.
जल्दी समझ लेते हैं. एक बार यू का प्लस हो रहा है और एक का माइनस हो रहा है, राइट?
ठीक, ओके सर.
ये एक्स एक्सिस है, ये वाई एक्सिस है, ठीक है? ये एक्स एक्सिस है, ये वाई एक्सिस है, राइट? तो वाई एक्सिस के राइट हैंड साइड में क्या होगा? प्लस. वाई एक्सिस के लेफ्ट हैंड साइड में क्या होगा? माइनस. यस और नो?
यस सर, यस.
राइट? ठीक है, लेट अस अंडरस्टैंड दी प्लस माइनस फर्स्ट, राइट? एक्स एक्सिस के ऊपर क्या होगा? प्लस. एक्स एक्सिस के नीचे क्या होगा? माइनस. यस और नो?
यस सर.
राइट? तो वही चीज है, एग्जैक्टली वही चीज है। अभी जब मिरर है ना, मिरर यहाँ पर बना दो,
ओके ओके
ठीक है। ये हो गया पोल P, पॉइंट P, दिस इज द पोल, दिस इज द पॉइंट P. सो एनीथिंग विच इज ऑन द राइट हैंड साइड ऑफ P इज पॉजिटिव. ये origin, this is the origin, nothing else. Consider this is to be the origin. Suppose the mirror is not there. Suppose the mirror is not there. So definitely this is 0, 0. P point is 0, 0. Right? So anything which is towards right of point P is positive. So this is positive 1, this is 2, this is 3, this is 4, this is 5. Similarly, anything towards left of P is negative. This is -1, -2, -3, -4. Above point P is positive, +1, +2, +3. Below point P is negative, -1, -2, -3. Is it clear now? At least this part is clear?
यस सर
Okay, great. Now let us first see the first figure. पहला फिगर हम देखते हैं, ठीक है ना, पहला फिगर हम देखते हैं एक बार. Let us try to see the first figure.
गॉट इट सर, समझ आ गया सर। वो आप पॉजिटिव नेगेटिव अभी बताया ना, तो नाउ वी कैन कोरिलेट। गॉट इट सर।
Okay, great. Fantastic.
सर
ठीक है?
वन मोर क्वेश्चन सर, दैट
Yeah.
एम जब नेगेटिव होगा देन ऑलवेज द इमेज विल बी रियल, राइट सर?
देखो ये हमेशा ना,
ऐसा हाँ
ये कंफ्यूज ऐसे याद रखने की कोशिश करोगे कि अगर नेगेटिव हो गया तो इमेजरी होगा, पॉजिटिव हो गया तो रियल होगा, ऐसे कभी मत याद रखो, ठीक है ना। याद रखो डायग्राम के हिसाब से, ठीक है।
ओके
ट्राई टू रिमेम्बर इट विद रेस्पेक्ट टू द डायग्राम, राइट।
ठीक है
इमेजिन द
सर।
डायग्राम, राइट हैंड साइड ऑफ पॉइंट पी इज पॉजिटिव, ठीक है, लेफ्ट हैंड साइड ऑफ पॉइंट पी इज नेगेटिव, ठीक है। सो
वी गॉट इट।
इफ इमेज इज बीइंग फॉर्म्ड हियर, ठीक है ना, अगर इमेज ऐसे फॉर्म हो रहा है, if this is the image, ये मिरर हो गया, this is the mirror, ठीक है। This is the mirror, right? So this side is positive, this side is negative. So whenever we are placing the object will always be real na, object cannot be imaginary, object cannot be imaginary, object will always be real, object तो हमेशा क्या होगा, real होगा, right? तो ऑब्जेक्ट के लिए u का साइन, u जो होगा it will always be in minus, negative,
ओके
-5, -10, -7.5 like this. Now the image, it can either form towards left, the image can be formed here, or the image will be formed here, right? So if it is formed here, means the value of v will be positive. If the image is formed here, then the value of v is negative. Okay. Now to avoid confusion, because you'll have to study so many things, remember so many formulas, just don't remember ki positive negative, just simply try to draw the diagram. थोड़ा सा diagram एक दो बार if you draw it, things will be clear, you will not make mistakes, because very simple formula, right? So if it is negative, means if the value of v is negative, coming out to be negative, if the value of v is coming out to be negative, when it is possible negative, if it is formed towards left of the mirror, so towards left of the mirror means real image, right? And if v is positive means it is must be formed towards right of the mirror. Right of the mirror means inside the mirror ना, mirror के अंदर form हो रहा है. Mirror कहाँ से देख रहे हो? Where you are looking at the mirror from? You're looking at the mirror from this side. Where are you looking at the mirror from? You're looking at the mirror from this side. So this is the inside of the mirror. So if the image is formed inside, V will be positive. If V is positive, image is imaginary. Is it clear? Anybody has
Clear,
any
sir.
doubt?
Sir, in first case, why we are not considering the rays passing through center of curvature?
In the first case, can you repeat please?
Why we are not considering the rays passing through center of curvature?
Okay. You can consider. Okay? You can consider. Okay? That is not a problem. Because only 2 rays are enough. Okay, na? Try to understand my point. Because only 2 rays are enough. It's not getting erased now. Okay. That is because only 2 rays are enough to make a draw an image. Okay. If you want to draw an image, okay, find an image, 2 rays are enough. Okay, ना? एक ray से तो पता नहीं लगेगा. You will not be able to draw with 1 ray. So you need at least 2 rays. Suppose this is the mirror. Suppose this is the mirror. Okay. This is the pole. This is the focus. This is the center of curvature. Now suppose image is here. If it is left of the focal length, suppose the object is suppose left of the focal length. It is towards the left of the focal length. Focal length के left hand side में. If the object is towards the left of the focal length, then the 2 rays that I'm considering is, one ray is this one. Okay, I'm drawing it with green. It's going parallel to the principal axis. Then after reflection, it is passing through the focal point. The second ray I'm considering is this one. One ray is passing through the focal length. Then after reflection, it is going this way. Okay. So now, wherever the 2 rays are intersecting, we will get the image. Image बन गया? We are able to draw the image? Yes or no? Wherever the 2 rays are intersecting, that is where we will form the image, right? Now, when the object is lying here, when the object is lying between focal length, focal point and pole, that time it is difficult to draw these 2 lines. Now suppose your object is here. This is your object. Okay. Drawing the first line is easy. Now the second line, drawing the second ray, right, passing through focal length, that is not possible in this case. But we need two images, 2 rays. Only then we'll be able to form the intersection and find out the. Only then we'll be able to form the intersection and find out the image, position of the image. Now here we cannot draw a second line through the focal length. Huh? It was possible in the earlier case, but here we cannot draw a second line passing through focal length because focal length is towards left. It is not going to intersect. So what we are doing, we are taking a ray, right? We are taking a ray which is passing through the center of curvature. So a ray which is passing through the center of curvature, it will also get reflected back through center of curvature. Now we can actually extend them and take the. Now we can actually extend them, and then wherever they are meeting, we can form the image. Wherever they are meeting, we can form the image. Right, Rakesh? Was I able to explain it to you?
Yes, sir.
Okay, Radhalingam, can you tell me where is your problem? Is it clear? This diagram is clear, Radhalingam? The problem is clear, entire problem is clear. Shall we move on to the next problem? Or you want me to explain it once again? Okay, great. So let us summarize. Okay, for convex mirror, let us summarize for convex mirror. So convex mirror, okay, the images can be both real and imaginary, right? The images can be real and both imaginary. Now, I want all of you to draw a diagram. Now, I want all of you to draw a diagram where in convex mirror, the object is placed at the focal length. If the object is placed at the focal length, where, what, tell me what is the kind of image? Real image. Okay. What is the, where is the image formed? Not convex, sorry, concave. I'm talking about concave only. Concave mirror. Rakesh, concave mirror, object placed at focal length. Okay. Concave mirror, Uttam. Concave mirror, object placed at focal length. Okay, just do a little bit of research on this. This will be homework for all of you. Okay, do a little bit of research on this. It will be a small homework for you, all of you. Do a little bit of research on this. Okay, think. Okay, think and come tomorrow. Tomorrow again we have a class. Tomorrow again we have a class. We'll discuss in next tomorrow's class. Okay. Okay. Now let us do another question. Let us try to do another question. Yes, Rakesh, tell me.
Maybe the answer is no image, sir.
Yes. What I want you to do is, it is very simple thing. What I want you to do is at least search. Again, try to read, try to search, try to find out the answer. You might be knowing it. I'm not telling the answer yet. You might be knowing it, but my main motive is that when if you try to open a book, right, or suppose you search the web, you'll get to see 5, 6 other things apart from that. That will just enhance your knowledge. Getting my point? It's a very simple question. Very simple question. Might be you know the answer. Might be you are answering it correctly, right? But what I want that you do will you spend 5, 10 minutes of your time after the class, right? Might be you open a book and see if you can get to the answer, right? Might be you surf the internet and try to see if you can get to the answer, right? Nowadays NCRTs, each and everything are available online. You can try to figure it out there. Now when you open the book and see, you'll get to see at least 4 or 5 other things also, right? So when you see the 4 or 5 other things, because we have only 1.5 hour of class, I am not be able to teach you everything. But if you just devote 4 or 5 minutes onto the book, you'll get to, you'll get to learn a lot many other things also. That is my main motive. Okay, let us do question number 2. This question will be on a convex mirror. This question will be on a convex mirror. At what distance from a convex mirror of focal length 2.5 meter should a boy stand so that his image has a height equal to the half of the original height. The principal axis is perpendicular to the height. Okay, try to solve this question.
Sir, is it a convex or concave mirror, sir?
This is convex. This is a convex mirror. Okay,
Convex.
this is a convex mirror. Okay, so the formula remains same. Only thing is that, see, let me see. The formula remains same. Only thing is that how you draw the arrows will change. You can see, let me say this is the object. This is the object. Okay, this is the object, and I was drawing the figure, that's why I was speaking. Okay, so this will be the V. So what will be the value of V? Definitely V is towards the left of point P, so we can say it is negative, right? Minus 2.5. The value of V is minus 2.5. Sorry, sorry, sorry. Focal length is given. V is not given. Focal length is given. Sorry. Right? So this is the value of V. V will be definitely in minus. Okay? Not V. Sorry. So this is the object. So here is the boy standing. Here is the boy standing. Okay? This is the height of the boy. Let me say the boy is standing at a distance of U. So here U is negative for sure. Here U is negative for sure. Right? Rakesh, it is not 0.33. Let us try to see. Let us try to see. Okay? So you can see in this question, the value of U will be definitely in negative, right? But the focal length, at it is towards the right of the mirror, the focal length will be positive. The value of focal length is given, it is 2.5 meter. The value of focal length is given, it is 2.5 meter. So how to draw? Here, let me take a ray which is parallel to the principal axis. So after reflection, it will go like this. So when you extend the ray backwards, it will come and meet at the focal point. It will come and meet at the focal point. So this is how you are going to draw the first ray. This is how you are going to draw the first ray. The first ray that is going parallel to the principal axis, after reflection, it will diverge away because this is a convex mirror. Now if you extend the reflected ray backwards, it will come and meet the principal axis at the focal point. Okay. Now the second ray that you are going to take here should pass through center of, it should be directed towards center of curvature. It should be directed towards center of curvature. It should be directed towards center of curvature. And after reflection, it will take the same path. It will take the same path. Right? So wherever these two lines, the green one and the blue line, are intersecting, you're going to get the image there. You're going to get the image there. Right? So you can see for convex mirror, the images, whatever. Now see, whatever might be the distance U, whatever the distance U, right? The image will always be imaginary, it will be erect, and it will be smaller in size. It will be in smaller in size. Image will always be imaginary, it will be erect, and it will be smaller in size, irrespective of the position of the object. Irrespective of the position of the object. Right? This is for concave mirror. This is for concave mirror. This is for concave mirror. Sorry, not concave, convex. This for convex mirror. So let us try to use the formula and see what does our formula gives us. So according to the formula, okay, according to the question given, the magnification is minus v by u. That should be is equal to, the magnification will come out to be half. Why positive? Because the image is erect. Right? Why have I considered the magnification half? Because the image is erect. A convex mirror will always form erect image. Uttam, you are right. Your answer is right. Minus 2.5 meter. So this implies, yes, right. This implies v is equal to minus u by 2. Now, all of us know the equation of mirror. 1 by u plus 1 by v is equal to 1 by f. This implies 1 by u plus 1 by minus u by 2 is equal to 1 divided by 2.5. This implies it will become 1 by u plus 2 will go to the top plus 2 by minus u. So if you take LCM, 1 by u minus 2 by u is equal to 1 by 2.5. This implies minus 1 by u is equal to 1 divided by 2.5, or this implies u is equal to minus 2.5 centimeter. Is it clear, all of you? Yes, meter, right. It should be meter. It should be meter. Thank you. Tirthankar, is it clear?
Clear, sir. Understood, sir.
So you see, these are the only two things that is there in a convex mirror. Okay? So what are the different types of questions that can be asked? Okay? If it is a most chances are there if from mirror questions are being asked, so definitely uh, can be asked, right? From this part, formula based. But more important is refraction. Okay? Because if you see airport safety, air safety, right, aircraft safety, air safety, right, we deal with more of reflection rather than reflection, refraction, right? Because there is a windshield, right? Whenever the pilot is seeing through the windshield, yes, definitely reflection will also be there, but refraction has more role to play. Refraction has more role to play because the density of air also changes as we go to the top, right? So what you see from the top is quite different, right, than what you see from the bottom. from the top. Means what I'm saying is that when you are in an aircraft, suppose you are a pilot, you're looking at the ground, right? Or you are supposedly looking at the ATC tower, right? Or air traffic controller tower, or whatever it is, or you are looking at the runway, or whatever it is you're looking at, right? Things might not be exactly positioned where it seems like, right? So yes, as a pilot, you should have the knowledge of refraction a little bit, right? Now, if the pilot requires this information, so definitely the air safety officer has knowledge, at least technical knowledge, greater than that of the pilot, right? So that he can evaluate each and everything, if it is okay, not okay, if any color is being, if any thing is being painted, if it is being that the right color is being used, will it be visible for the pilot? Lot many things needs to be checked, and definitely here knowledge of refraction is more required, right? So we will proceed on to the refraction part quickly. We will go through the refraction. Okay, till now whatever we were doing was reflection. Now what we are going to do is refraction. We will have a quick understanding of refraction. Okay, refraction of light. Refraction of light. So let us try to understand quickly refraction of light. So let me say this is a glass material. Okay, this is the glass material. Okay. And suppose a incident ray comes and hits the glass material. Okay. So the part of the incident ray will be reflected. Part of the incident ray will be reflected. Part of the incident ray will be reflected, and a little part of the incident ray will be refracted. And it is all dependent on the kind of material that is being used. If it is the common normal, it's a common normal. This is how it will look like. Okay, so this is the incident ray. This is the reflected. Little bit, some part will always be reflected from the surface. What we have seen, right? If this angle is angle of incidence, this angle will also be angle of incidence. This is the refracted, F R A C T E, refracted ray. So let me say this angle is R. So I is angle of incidence. R is angle of reflection. Here angle of incidence and angle of refraction are not same. See, here the angle of incidence and angle of refraction are not same. Okay. So these are guided by a law which is known as Snell's law. Right? The Snell's law says that Snell's law says that sine of angle of incidence divided by sine of angle of refraction is equal to v1 by v2 is equal to mu2 divided by mu1. What is v1 here? v1 velocity of light in the medium 1, v2 to mu1 mu1. This law is known as Snell's law. This law is known as Snell's law. Okay, so we will end today's class here itself. Okay, we'll end today's class here itself. Let me ask you, if you have any doubt in today's class, let me know. Okay, let me know. Do revise. Do you want me to continue? Because the class timing was given as 1.5 hours. Uh, okay, let me not continue it. You also take rest and revise whatever is there. Right. So tomorrow we'll do the refraction part. Okay, na? Refraction for through one surface and refraction through a lens. That is we'll do. And again tomorrow will be a highly numerical part. Okay, highly numerical part. So just be prepared. Just be prepared. We'll first see what is critical angle, total internal refraction, and apparent depth, and then we'll move on to uh, questions from lenses and refraction through from one medium to another medium. Okay. ठीक है, thank you. If you have any doubt, you can ask, or I'll just end the session. Okay, did you find the speed of the class okay, or do you think I should increase the speed of the class a bit, or do you think should I make it a little bit slow? I hope that you are able to understand the two problems that we have done. Okay, fine. So in this speed, I think we will be able to comfortably complete tomorrow optics. Okay, then. Thank you. Thank you. Good night, all of you. Good night. Good night. Thank you.